Assalamualaikum. Today I would like to present and we like to present our last lab of BELK 4843 Electromagnetic Compatibility, which is lab 3. Uh, Topic testing of earthing system on earth resistance measurement using three pole method. We are from group A. The objective of this lab is first you have to understand earth resistance measurement using the three pole method. So you have to learn the all the methods from this lab. Next, you have to study the relationship between measured earth resistance and distance. Next, you to compare earth resistance between single and multiple earthing system. So the final you can get the how much the ohm that you get and how the circuit works to show the ohms from the measurement.
So now this is our equipment use. We have five equipment for this lab. Number one is existing earthing system, earth electrode E. And the second one, earth resistance measuring instrument with three pole or four pole. And then auxiliary test sticks, connecting wires or test leads. And the last one is measuring tape.
For component description and function, first, earth resistance tester. It's used for measure earth resistance value. Second, measuring tape. This tape used to measure distance between electrodes. Next, auxiliary test sticks S and H is to provide reference points to accurately measure earth resistance during testing. Next is existing earthing system, earth electrode E. It for safely direct unweighted electrical current into the earth to protect people and equipment. And the last is connecting wire. It's to provide a low resistance path for electric current to flow between different components in an electrical circuit. Okay, next for the method, okay, in this picture we see there has a EX, SY and HZ, which EX is earth electrode under test, as HZ is the current auxiliary electrode, SY is potential auxiliary electrode.
Alright. Next, I will explain to you about the procedure. As you can see, the diagram at the right, you can see is the connection of this earthing, grounding the cable to parallel it to get the minimum ohm. Alright. The first procedure is place the earth resistance tester near the earth system under test within 10 meter. You have to clean the earth electrode contact point before connection to prevent from dust and any problem. Connect the tester to EX and HZ and SY. uh, Measure distance between EX and HZ 10 times Earth road length. Place SY at 10% of the distance and record resistance. You have to repeat measurement at 20, 30, 40, 60 and 70%. Connect a second earning system in parallel using proper wire to make a lower ohm. So you have to repeat the system measurement for multiple earthing system. Uh, Next, the things you have to do is record data in a table and plot resistance versus distance graph. Compare results between single and multiple earthing system.
Moving on to our primary findings, this result table illustrates the relationship between the distance of the grounding rods and the measured resistance in ohms. We have tested three different configuration, which is a single rod, two rod copper, and the three rod copper, across a distance range of 3 to 7 meters. If you look at the data, you will notice two very clear trends. Number one is distance correlation. Regardless of the configuration, as the distance increases from 3 meters to 7 meters, the resistance also increase. For example, in the single rod setup, resistance climb from 292 ohm to 317 ohm. And the second one is configuration impact. More importantly, as we add more rods to the system, the resistance drops dramatically. By moving from a single rod to a three rod configuration at the 3 meter mark, we see a reduction from 292 ohm all the way down to 90.1 ohm. These numbers provide the raw evidence that the quantity of rods is a much more significant factor in reducing resistance than the specific distance of the installation. To make these findings more actionable, we have summarized the data in this comparison table, which is we have a single rod. The single rod configuration represents our baseline with a resistance range of 292 ohm to 317 ohm. It shows the highest resistance. This indicates a limited ability to disperse current into the soil effectively, which could pose a risk in high load scenarios. And the second one is the two road parallel setup. It shows a significant improvement by simply adding a second rod. We have cut the resistance by more than half, bringing the range down to 130.9 ohm until 150.2 ohm. This demonstrates a much improved grounding performance. And the last one is the three road parallel setup. It is clearly our top performer. It provides the lowest and most stable resistance range, staying between 90.1 ohm and 107.7 ohm. In conclusion, for any installation requiring a high degree of safety and a bit stability, the three-rod parallel configuration is the most effective choice for ensuring a reliable grounding system.
So for my part is I will present about graph or measure resistance versus distance. So as you can see, this graph is a relationship between the number of rod and electrical resistance. So so the key is we can see they have three, which is blue, orange, and green. So as you can see, that the most immediate takeaway is the significant drop in resistance as we add more rods. So the blue lines is show that it's a single rod, and it sits on the highest with a resistor level around 300 ohms. When we move to the red lines, which is two rods, the resistance drop by more than half, which is uh, maybe around 150 ohm until 100. And then the resistance on the green line, which is a three rods, provide the lowest most efficient grounding at raw at the 100 ohms. So I will explain the distance factor, which is if you notice that all three of the line have a slight upward slope. This indicates that as the distance between the electrode increase, there is a marginal increase in measure resistance. Though the number of rods remains the primary factor in overall performance. So I will conclude the graph is the number of grounding rod is the important. The more the grounding rods and the most effective way to lower soil resistance. So this is very good for grounding and it will be safe and more stable grounding system that using three rods compared to the one rod or two rod. So the next slide is the best result is achieved using three rod in parallel. So which is the previous slide that we see. The three rod that we use are the most effective and the lowest result of the ohms that we got. So it must be in parallel positions to make sure it got the lowest ohms, which is our group has achieved between 90.1 ohm until 1700.7 ohms, which is significantly lower compared to the single rod, which is 292 ohms until 370 ohms, and the two rods parallel, which is 130.9 ohm until 115.2 ohms. This is occur because multiply rods increase soil contact area, which is when we put the rod maybe around 3, 4, or 5, that the cover area of the soil are increased. This is because every root that we put in the soil will cover one zone, and then if we times to 5 zone, it will increase the cover area. So and then it will provide parallel current path, which is the current will go through more smoothly, and the current not just go in one way but three or two and more depends on the roots. The more the root we put, the more the current will go through the roots, and it will reduce soil resistivity effect and improving grounding effectiveness and stability, which is I will compare it when we have a biggest like uh, 3 or 4 line of the highway. It will smoothly the traffic light, the traffic on the road compared to the one on road only, and it will produce the jam. So compared to the this and the situation on the highway, so the multiple road is we will assume they have a 4 or 3 highway path that will decrease the jam and the traffic load. So as you can see, this is sketch drawing that will get 10 ohm from the 90 ohms resistance. So as you can see, there has a 5 rod copper, and we will put 6 meter deep underground until it will enter the higher moisture zone, because higher moisture is very good for we get the lower resistance. So we put in a parallel position because parallel is more effective to get the lower resistivity. And then as you can see, the green line is the earthing cable. So the spacing of road is we put 8 meter because we want to the road cover the higher zone. So make sure the cover up of area is increased when we put. So meanings they have the if the deep is 6 meter or 4 meter, so the spacing we need to 2 times more, which is 8 meter. It depend on the deeps of the rod because this way will produce a lower resistivity. So as you can see, we put 5 rods in parallel and the depth is 6 meter and the spacing is 8 meter. This is will increase the conductor and will produce the lower resistivity value.
Okay, for standard cord providing less than 10 ohm according to Malaysia standard. First, the installation earthing system ensure effective operation of earth fault protection device. The earth resistance RE shall be kept as low as possible and must not exceed 10 ohm. It's measured using the vernier for probe method or equivalent. Okay, for standard measure MS1979 2015 electrical installations of building code of practice class code of practice 7 installation earth resistance shall be less than 10 ohm. Suruhanjaya Tenaga Malaysia ST guidelines for electrical wiring in residential buildings, requirement for earth electrode resistance not exceeding 10 ohm.
Okay, so now I will explain about the standard code for earthing resistance testing according to Suruhanjaya Tenaga. So, this standard code is used to make sure that earthing resistance testing is carried out according to the requirements set by Suruhanjaya Tenaga. So, based on the requirements set by Suruhanjaya Tenaga, enforcement letter issued by Suruhanjaya Tenaga, all lightning protection system, which is LPS, is designed to the installation must follow the code MSIEC 62305. For the simple terms, MSIEC 62305 is a guideline that explains how properly protect buildings from lightning. It also emphasizes the importance of having a good earthing system so that lightning current can safely flow into the ground. In conclusion, the Earth resistance measurement using the triple method was successfully carried out, and the results showed that the measured Earth resistance varies with the distance of the potential electron. So, the findings also confirm that if we use multiple earthing system, it can reduce lower earth resistance compared to a single earthing resistance. So that's why we get the best result, which is using parallel with 3 rods. So that and lastly, proper earthing plays an important role in improving electrical safety and overall system reliability. Thank you.